Let us talk about a differential equation. Now, if an equation contains a derivative, for example, dy over dx plus y equal to 0, it is a differential equation. Another example would be the partial derivative of u with respect to t would be equal to k multiplied by the second partial derivative of u with respect to x. Now, this is also another example of differential equation. Let's talk about how to identify whether the differential equation is ordinary or partial. So first, for ordinary, it only contains one independent variable. An example of this would be dy over dx plus y is equal to 0. You can see here, it only has one independent variable, which is x. Another sign is how the d is written in the equation. So if you see something like a straight letter d, it is an ordinary differential equation. Next up, for partial, it contains two or more independent variables. An example of this would be the partial derivative of u with respect to x plus partial derivative of u with respect to something like t equal to 0. You can see here that it has two independent variables, which is x and t. Another sign whether to identify an equation is partial is how this is written. So unlike this, d is straight. For this, it has a something like this curved line to it. How to identify whether a differential equation is linear or non-linear. So, for linear, the dependent variable, like y, appears only to have a power of 1. Next, its derivatives like y prime, y double prime, etc. also only has a power of 1. There is no multiplication between y and its derivatives. Example for this, like y multiplied by y prime, it cannot be exist in linear, or y multiplied by dy over dx, something like that, it also cannot exist. And also, there are no functions of trigonometric like sine, cosine, an exponential, or a logarithmic function. This does not exist in linear equation. So, for nonlinear, its dependent variable is raised to a power greater than 1. So, we can say it like 2, 3, 4, 5, etc. Its derivative can be also raised to a power greater than 1. So, let's say like y prime to the power of 2. Something like that. And its variable, like y, is multiplied by a y prime. Or when you say something like y multiplied by dy over dx, that is a sign of a nonlinear function. And also, if you see a trigonometric function, sine, cosine, something like that, or a logarithmic or an exponential, that is automatically nonlinear. So let's see its example. For linear example, it would be dy over dx plus 3y equal to 5. Some examples for nonlinear power would be dy over dx plus y squared equal 0, y prime to the power of 2 plus y equal to 0. So if you can see the difference here, for linear, y only has a power of 1, and also for its derivative, it also has a power of 1 automatically. You can see here that there is no y multiplied to its derivative, and also there are no trigonometric, exponential, or logarithmic function in this equation. So it is a linear differential equation. For this first example, you can see here that the dependent variable y is raised to the power of 2, so that is automatically nonlinear. And for this, its derivative y prime is also raised to the power of 2, which is greater than 1, so it is also automatically nonlinear. And some examples of this would be y multiplied by dy over dx would be equal to x, and dy over dx plus sine of y equal to 0. So you can see here, a variable was multiplied by a derivative. So if you see anything like that, it is automatically a nonlinear. And for this next equation, you can see here it has a trigonometric function, so it is also nonlinear. Next up would be identifying the order and degree of the equation. So first up, for order, the order is simply the highest derivative that is present in the equation. So let's say your highest derivative would be y prime. This is first order. Y double prime, it is second order. Y triple prime, it is third, etc. And for degree, the degree is the power of the highest derivative of the equation. So let's say something like your highest derivative is y prime, and it is raised to 3, let's say 3. And so your degree here would be equal to 3. If you see something like y double prime and it is raised to 2, the degree here is 2. And just in case you see a y double prime and this is your highest derivative in the equation and there is no like exponent, it is automatically 1. And so let us try this. Y prime plus y equal to 0. So the order for this equation would be first, because it has the first derivative, and so the degree for this, it has an exponent automatically of 1, and so the degree here would be equal to 1. So let's say something like y double prime and it is raised to the power of 2, and so your highest derivative here is y double prime, so it has an order of 2, or let's say second order, and so your degree here would be basing according to the highest derivative exponent, so it has an exponent of 2. So let us try some practice problems. So first on our problem, the second derivative of x with respect to t plus k squared multiplied by x plus 0. So let us identify whether it is an ordinary or a partial differential equation. So we can see here, it has only one independent variable, and also another sign would be the letter D. It is straight, so we can say that this is an ordinary differential equation. Next up, to identify whether it is a linear or a nonlinear equation. So you can see here, the dependent variable x does not have an exponent that is greater than 1. So, and also we cannot see any trigonometric, exponential, nor logarithmic function here, and there is no variable that is multiplying in this derivative. And so we can say that this is a linear differential equation. So let us see its order or the highest derivative. We can see here that this is the highest derivative. So it is, the order here is 2 or second order. And so based on this second order, it has an automatic exponent of 1 because there is no given. So the degree here is 1. For the next problem, y triple prime minus 3y prime plus 2y equal 0. Now, identify whether this is ordinary or partial. It is an ordinary differential equation, because whenever you're given a prime form here and not a derivative form, know that d cube y over dx cube is also equal to y triple prime, and also 3y prime would be equal to minus 3 dy over dx. So as you can see here, it also has a singular independent variable. So next up would be either this equation would be linear or nonlinear. Now, first up, there are no trigonometric, logarithmic, or exponential. And also, all the variables here and its derivatives have all the power of 1. So this is linear. Next up, let's see the order or the highest derivative. We can see here that y triple prime is the highest derivative. So the order here is 3. And so, based on the highest derivative, its exponent is automatically equal to 1. So that is its degree. Y multiplied by y double prime equal to x. So, whether this is ordinary or partial, let's identify. You can see here that if you rewrite this into its derivative form, it would be y multiplied by y double prime. So that makes it second derivative of y with respect to x is equal to x. So you can see here, it has a single independent variable and the d is not curved. And so this is ordinary. Next up, to identify whether it is linear or nonlinear. So we can already see here that it is nonlinear because a variable was multiplied by a derivative. You can see here, y multiplied by y double prime. A variable was multiplied by a derivative. So that makes it nonlinear automatically. Next up, to identify the order or the highest derivative. The highest derivative here is y double prime, which makes it 2. And so, the exponent of the highest derivative is equal to 1. So, the degree is equal to 1. Next problem. The second partial derivative of u with respect to x plus the second partial derivative of u with respect to y plus the second partial derivative of u with respect to z squared equal to 0. So, let's identify whether this is ordinary or partial. So, you can already see here that it has 3 independent variable, and also the d here has a curved line. So this is automatically a partial differential equation. Next up, to identify whether it is linear or nonlinear. So if you can see here, all derivatives have a power of automatically 1, and we cannot see any trigonometric, logarithmic, or an exponential function. So this is a linear differential equation. Next up, let's identify the highest derivative. So you can see here, they are all the same because they are the second partial derivative. So the order here is 2. And so the degree or the exponent of the highest derivative, you can see here, it is all automatically 1. The fourth derivative of t with respect to x would be equal to w of x. So let's identify whether it's ordinary or partial. You can already see here it has a singular independent variable, and the d is in normal shape. So it is an ordinary ODE. Note that ODE is ordinary differential equation. So let's just put that as ODE. And next, is it nonlinear or a linear equation? You can see here that the derivative here only has an exponent of 1. So it is a nonlinear. And also because you didn't see any trigonometric, exponential, or logarithmic, so this would be linear. And so the highest derivative in here would be this, and this is according to fourth derivative, so the order here is 4. And so the exponent of the highest derivative is also once again 1, so that would be the degree. So next problem, x multiplied by the second derivative of y with respect to t minus y multiplied by the second derivative of x with respect to t equal to constant or constant sub 1. So you can see here that t squared here. So it only has one independent variable. So this would be ordinary differential equation. And so identifying whether it is linear or nonlinear. So you can already see here that a variable was multiplied by a derivative. So it is a sign that it is a nonlinear equation. Next up would be the order. The highest derivative in this equation would be 2. And so the exponent of the highest derivative is also 1 once again. X multiplied by y double prime to the power of 3 plus y prime to the power of 4 minus y equal to 0. So, whenever you see an equation that is in the prime form and not a derivative form, it is automatically an ordinary differential equation. So, next up, is it linear or nonlinear? You can see here that a variable was multiplied by a derivative, and also because the derivative has an exponent that is greater than 1, So that is a sign that is a nonlinear equation. Next up would be to find the highest derivative. The highest derivative here is this one, which has a derivative of, the power of derivative of 2. And so based on the highest derivative, the degree or the exponent of it would be equal to 3. So the degree would be 3. Lastly, L multiplied by di over dt plus R multiplied by I equal to E. Now, in differential equation, whenever you encounter a capital letter such as this, these are constants and not variables like x. So, don't misunderstand that these are variables. No, these are constants. Keep that in mind. And so, let's identify whether ordinary or partial. It is ordinary because it only has one independent variable. Next up, linear or nonlinear. Keep in mind again, this is a constant, not a variable. So it is not a variable that is multiplied by a derivative. It is a constant. And so, we did not see any trigonometric, logarithmic, or exponential. We did not see any power that is greater than 1. So this is linear equation. Next up would be to identify the order. We only have one derivative here. So this would be 1, and that is the order. And the exponent of the highest derivative, it is equal to 1.